everybody. Welcome to the latest episode of the Mobilecast. We're coming to you live from the Mobilecast studio here in Oakland, New Jersey, and I'm your host, Brian Katz. Today's show is going to be fun and really interesting as we have a great topic and a really fun guy to talk to. We're going to be talking about identity and access management as it relates to mobile computing. And I'm really stoked about our guest, Paul Madsen, who is a real expert on tonight's topic and an absolutely hilarious on Twitter. If you don't follow him, you should. Paul works from the CTO's office at Ping Identity and has a great background. Welcome to the Mobilecast, Paul. Go ahead and introduce yourself.
Thanks, Brian. I'm happy to be here. As you said, I work at Ping Identity. I work in the CTO office there, and we're sort of loosely mandated to look at new trends, new use cases, new issues that our customers will be facing, and clearly mobility is a big one. So I work in a security company now. I don't have a security background. I actually have a physics background, but when I realized, I guess 10, 15 years ago that wasn't going to keep the kids in diapers, I switched, and I actually worked in technical documentation for a while, and the underlying infrastructure for technical docs was XML. And 7-8 years ago, XML emerged as a pretty important piece of a couple of security standards, one of which was SAML. So I jumped onto XML for security, participated in the development of SAML, the Security Assertion Markup Language, a couple of other XML-based security standards since then, but lately I've been jumping with everybody else onto the JSON bandwagon and switching to some of the more recent JSON and cool kid standards like OAuth and OpenID Connect. What else? I'm Canadian, proudly so, if somewhat apologetically.
So now, wait a second. First of all, you've been in security for long enough. You've been there more than 8 years at this point, it sounds like. So you can't say you don't have a security background, but you actually have a Bachelor of Science in Physics?
Well, if we're going to be precise, I have a doctorate in physics, but
wow,
don't particularly use that much in my day-to-day work.
No, it's interesting. No, I actually was a double major in college in physics and mechanical engineering. And in my junior year, I made the decision to go mechanical engineering only because junior lab was just you couldn't do both without 5 years, and I didn't want to do 5 years. So more power to you to go all the way to a doctorate.
Well, you probably made the right decision. I don't regret it, but I wouldn't claim that it actually has benefited my current career. But regardless, that ship has sailed.
And now you're in security. So what we're here to do is talk a little bit about identity and access management. So let's start with the generalities before we kind of get down to mobile. So, really good way to level set this discussion. So as we get this picture, tell us, give us a good baseline of where we're starting, and, then we'll move on from there.
Sure. So at its most basic, I think identity management is meant to make possible some user sitting in front of some computing device accessing some application. And, the device will change, and we're seeing that now. The application, the mechanisms by which the application functionality is accessed will change. We're seeing that now. Where the apps are hosted will change. Clearly, we're seeing that with the cloud. But all of those variations and permutations don't change the fact that, it really just boils down to some user needs to be able to access an application. And the application, if it's anything other than trivial, needs to make sure that user should be allowed to see that application, whether it's, personal, private information or business data that only particular users should be allowed to see. So identity management is all the underlying pieces and infrastructure that make that happen.
So in other words, what we're saying is when you run an app, the app needs to know who you are and whether you have permissions to come out and play.
Correct. And historically, the mechanism by which an app did that, maybe sitting on a mainframe or older, was that a user would have been issued some sort of password, and they would directly authenticate, present that password, maybe some account name, and the application would bear the burden of authenticating that user. Check the password, see if the password's valid, see if the user's good, and see if they should be authorized and allowed to do what they're asking to do. And that's great until the nature of the applications and the number of the applications and the location of the application means that passwords just don't work anymore. We're seeing that. If you think about the number of SaaS that a typical enterprise employee might use in a day-to-day basis, I don't know. I probably have about 10 different SaaS providers that Ping has purchased the services of to help me do my job. I don't think I'm, irrepresentative there. I'm sure some have more, some have less. But 10 apps, if I'm expected to have a password for each of them, then I, as a user, and consequently myself as an employee, bear the burden of managing all those logins, and inevitably my productivity is going to suffer.
Well, your productivity suffers, and you get to the point where certainly until recently, when you had apps that could help you with this, you were using sticky notes, you were writing them down somewhere. They became very difficult to remember, or you use password or password 123, which I think password is the most popular password out there, and then 1, 2, 3, 4, 5, 6, 7, 8 is the next one. From what I've seen recently.
Those were actually good passwords. Even more serious than poor passwords is reuse of passwords, or they're not independent, those risks, because if I use a bad password, or even if I use a strong password at a site that is hacked, and that password is breached, the risk is not limited to only that one site or application if I've used that same password elsewhere.
So you talked about password reuse, which really brings us to the next part of the discussion of what is single sign-on.
So single sign is a model of user authentication into applications that presumes that a user doesn't actually need to have a password at every application they want to use. Instead, in one manifestation of single sign-on, they authenticate to some other entity, and that entity, perhaps it's their enterprise, or perhaps it's Facebook in the consumer world, that other entity asserts the relevant pieces of identity and identifiers about that user to the application site.
So is it fair to say that whatever that piece is really becomes the identity authority? It says who you are and passes that information along to the app that you want to use.
Exactly. And depending on the nature of the relationship between the app and the authority, or the identity provider, sometimes referred to, they may well have come to an agreement as to what pieces of identity need to be asserted. In an enterprise, it's probably going to be my role. What do I do at the enterprise? Because the applications will want to make an appropriate authorization decision based on that role.
Yeah. So essentially, do I have permission to see this data or that data? And, what do I have permission to, what don't I? I probably shouldn't see HR data, but I should be, being that I do mobile at my job, I should be able to see information about mobile devices and everything else.
Right. Now, that sort of granularity of authorization decision probably sits at the application, right? And based on the attributes about your role at your company, it's the application that can make that authorization decision. It's unlikely typically that your enterprise would be asserting that you have specific permissions to do specific things at the applications. It can work that way, but typically they assert identity attributes, and then it's the application that owns the decision about what you can do.
Okay, so single sign-on's been around for a while. We've taught, we're starting to get a handle on having an identity authority, and it asserts who you are.
Yep.
And then the app has the role. So single sign-on has been played with web apps forever. I mean, I remember using it back in 2000, and probably much longer than that. Not necessarily well. I think it's grown up a little bit. But can you explain how it works for a web app? Because I think that'll make more sense when we get to start talking about mobile apps in a couple of minutes.
So there's a number of standards that have been defined over the last 7-8 years that define via the browser, because a web app is going to be accessed in a browser of some sort, so that the standards stipulate kind of a messaging pattern between the application, some website that the user is trying to access, and the identity provider, some other website that can authenticate, actually log the user in, maybe with a password, maybe with something better than a password. So the standards stipulate how those two websites communicate amongst themselves about that user. So if, for instance, I start off at the application and I say I want to log in, typically that application website or the service provider will give me an option to log in directly, if I have a password there. But also they might give me an option to specify I want to log in via SSO. Maybe they give me a text field that I can type in my identity provider, my enterprise or equivalent. Alternatively, they might discover that information by asking my email, etc. So there are ways for the application to know, for a given user, where do I send them to be authenticated. Once the application knows where the browser should be sent, then the standards stipulate what parameters should be passed on those 302, those browser redirects to that other website, the IDP.
Identity provider for
So you mock my acronyms sometimes, but it's taken me a while to get used to the M*M library.
Yeah, well, pot calling kettle black here. Us mobile people have probably 50 to 100 acronyms that we will use interchangeably, and it really doesn't matter. We're quite free with them. So
every community has that. It's how we keep out outsiders.
So you're talking about identity providers. You've kind of explained how it works with web apps, but you keep talking about standards, and I've heard about a lot of these different standards: SAML, OAuth, OAuth 2, JSON. We go through all these, but to be honest, most people get so technical, start drawing these diagrams that take up 2-3 pages to explain how they work together. Can you explain a little more simply what some of these are?
So there are a number of standards. Historically, there have been standards that have emerged in different spaces. So SAML, the Security Assertion Markup Language, was defined to meet the use cases of the enterprise and more recently the cloud, SaaS providers, etc. So the expectations and the security requirements of SAML are very different than a single sign-on protocol that emerged to meet the expectations and security requirements of blogging or tweeting, such as OpenID 2. So there's always been a number of different protocols that can be used for single sign-on, but for the most part, there's been a reasonable separation as to when you would use one and when you would use the other. If you care about security, and this is vastly oversimplifying, if you care about security, if the nature of your application is sensitive for one reason or another, then you're probably going to be thinking about using SAML. If you care less about security and you want a more dynamic trust model between parties, and you want it easier for developers to add SSO to their applications, then historically you would have been looking at OpenID 2. So that and those were both standards, quote unquote, that emerged to meet the browser SSO use case. So 5 or 6 years ago, the mechanism by which that first website would call the other API and be able to access Paul's calendar data is the first website would ask me for my password at that second site. And they'd effectively impersonate me because they'd present my password, and from the point of view of the site hosting my calendar, well, that site has my password, so it must be valid. Basically, it's me. Now that's been referred to as the password anti-pattern because it's using passwords inappropriately. I'm necessarily sharing my password with a site that I may not even particularly know well or fully trust. There's a lot of other issues with that model of enabling this sort of API access. So OAuth 1 emerged 5 or 6 years ago to mitigate that. And OAuth, in its earliest form and more recently OAuth 2, the evolution of that, said you don't ever want to present a user's credentials directly on that API call. What you want to present as the means of authenticating API calls is a token, some security assertion or string that effectively represents the user and potentially represents the fact that the user had issued their consent for this API sharing to happen.
So if I simplify that would kind of be, for example, I walk into a bar, I show my ID, and they give me a wrist bracelet that says, okay, you're over 21, we've represented that, and now anytime I show that wrist bracelet, it entitles me to get a drink.
That's a great example. A valet key is oftentimes given as another example because the valet key that I might hand to the valet has a limited set of permissions associated with it, as opposed to the key that actually starts the engine and allows the car to be driven away.
It can't open the trunk. It can't do some of the other things, but it allows the valet to park the car and drive it around and get it where you want to do, but they don't have rights to everything in the car.
Exactly. And that it's that constrained granularity that OAuth makes possible, as particularly compared to if I had actually given my password to a site or given my driver's license to the bartender. It's that relative control that I have with a token as opposed to the more fundamental password.
Okay, so now does OAuth, I'm going to guess, stand for Open Authentication? Just to guess.
It originally stood for Open Authorization because the initial use cases and for many the use cases that are relevant still had a sort of a semantic of a user giving their consent to some API operation happening. So there was this authorization or consent field to how the protocol was used, and it's still used in that manner in many cases. OAuth's kind of grown since then. It's more of a framework than a simple protocol now, and it can be used to support that sort of delegated consent or authorization use case, important on the consumer web. But it can also support a more straightforward authentication model. It's not clear how relevant it is for an employee to give consent to some app that they've installed being able to access some CRM data or a colleague's calendar. So OAuth remains relevant in the enterprise, but that consent piece that's so critical to the consumer world, it doesn't always apply in the enterprise.
Really interesting because, I hadn't thought about it that way. So we've talked a little bit about SAML. We've talked about OAuth and OAuth 2. Anything else before we move to the next topic?
Well, so OAuth 2, as important as it is, it really doesn't have any sort of identity piece to it. It's moving these tokens around, but the protocol itself doesn't layer any sort of identity semantic or layer onto those tokens. So emerging over the last 2 years is a standard, and I know I'm just introducing more acronyms to feed fuel to your acronym overkill, is OpenID Connect. In some sense, it's an evolution of OpenID 2. in that it started in the consumer world to meet those SSO use cases. But it's grown beyond that, and it's expected that it can sort of cross the chasm between the consumer world and the enterprise and cloud world. It's a profile of OAuth 2. You can think of it as a thin identity layer built on top of OAuth 2. I mention it only because it promises to simplify the landscape, because OpenID Connect can do both what SAML does for browser apps, as well as what OAuth 2 does, enabling API authenticated and secure APIs.
So it allows us to more securely, by representing identity, which is what SAML does, I think, if I understand it correctly, give out tokens and allow this sort of stuff to interchange, enabling single sign-on and that sort of thing.
Definitely, but importantly and critically for many, it's built on JSON and REST principles as opposed to XML.
Okay, and
modern developers, the expectation is that OpenID Connect will be a far easier sell to integrate into their apps than SAML was.
Okay, so now that we have a little bit of understanding of some of these things, that, you know, one of the things that I see in the enterprise is that we've really been pushing for single sign-on on native apps, especially on mobile devices, tablets, phones, those sorts of things. Now, this can't be as easy as it is for web apps because, A, you're not in a browser, and, you know, B, you're on a different platform now. Granted, it still is a computer, but how, you know, where's this going? I know you have some really cool ideas on this topic.
Yeah, well, I think the industry is recognizing the need for a single sign-on experience for native apps, just as is currently possible for browser apps. What OAuth makes possible is that individual apps, whether a SaaS app calling a Salesforce API, or maybe it's an app developed by an enterprise calling some on-prem RESTful API, OAuth works fine in enabling and authorizing those individual apps on a case-by-case basis. So that's great, but if I have more and more native apps, and that seems to be the trend, how industry is moving, notwithstanding the promise of HTML5, the trend seems to be I'm going to have a lot of apps on my device. The default reality of OAuth is that I have to individually manage the authentication and authorization of each of those apps. So that arguably doesn't scale, and it particularly doesn't scale if each of those apps has a different concept of session and validity of token lifetimes, etc. So, and I think clearly the industry is recognizing that. So, what Ping, along with some others, is just on defining is a model whereby we can enable a single sign-on experience across those native apps, so that if I, as an employee, I open my phone first thing in the morning, I'd expect to log into my enterprise through some explicit presentation of my Active Directory credentials or equivalent. And then based on that, I'd be able to enjoy access to all the native apps that are relevant to my role installed on that device in a seamless manner.
So we got what we want to do. How do we do it?
Well, so the architecture that we're developing is still early days. Depends upon the idea of some sort of privileged application or agent running on the device, associated with my enterprise identity. It's to that agent that I explicitly log in on a daily or some policy-defined schedule. And then based on that explicit login or authentication, it's that agent that's able to go and get the tokens that the actual business apps need to do their job. So rather than each business app bearing the burden and corresponding to the user bearing the burden of individually obtaining the OAuth tokens that it needs for its API calls, the agent takes on that role. So a simpler trust model, arguably, but importantly, a far more usable model for the user.
So would a good way of, would a good analogy for this be if I go back to the 90s when EasyPass first came out, I'm hoping you have these up in Canada, we'd put that on the car. It's an RFID reader for toll booths, and a lot of the states didn't talk to each other. And what started happening was EasyPass signed agreements with different states, and it represented your identity as you went through the different tolls. So even though they didn't necessarily fully accept it, it could see who you were and could eventually charge it back to your account, which is similar to what we're talking about here. You're putting an agent or an app on the device that runs in the background that can do this identity and this OAuth piece and get these tokens and hand them to your native apps when you need them to. Is that it? Am I getting it correct?
Yeah, I think you are. I mean, maybe I'd tighten up the analogy a bit by saying if your EasyPass installed on your car, as you were going through a toll in a out of state, you were traveling out of state, your EasyPass that was associated with your identity in your home state would call back to your home state and say, here I am. I need a token. I need a ticket that will get me through this toll gate that otherwise wouldn't recognize me and wouldn't let me through.
Okay.
So the idea of some sort of privileged agent associated with a particular user taking on that responsibility for obtaining the tokens, the tickets needed to get to the application.
Well, this kind of leads me to, and I think I'm getting all this, which is great because I think you're explaining it really well here, Paul. And I'm going to use one of your acronyms here, IDAM, Identity and Access Management. It really seems like as an enterprise, we're going to need to build an ecosystem for IDAM, which allows us to do this sort of SSO and put the agent on the device and actually, be able to do this authentication and get these tokens.
Absolutely, and I think some of the pieces of that ecosystem are in place now. If you think about a container or a MAM provider, there is already on those devices a trusted agent, and it's one that can have an identity, an enterprise identity bound to it. Those agents already have a trusted relationship with the applications that run within, either logically or physically inside that container. So we're really interested in exploring how that existing deployed infrastructure, acknowledging that it's evolving, constantly, how we can sort of feed IDAM into that existing application model on the device.
So are you at Ping looking at, for example, creating some sort of SDK / API model that these agents can use, and then when I set up the framework using yours or somebody else's stuff, I have this ecosystem that I can now ask, and it has that framework and makes it easy because not everybody's going to use the same MAM, MIM, and MDM provider. So mobile device management, mobile application management, mobile information management, for those of you that aren't familiar with the acronyms. Is that how it's going to work?
Well, so you're asking if Ping would define our own SDK. There seem to be enough SDKs out there that an application developer, a SaaS developer, or some enterprise developer is being asked to write to if they want their app to work with the various MAM. I'm encouraged by the recent discussions that you've been participating in about the need for standardizing some sort of SDK so that an app need only write to a single SDK and then could have an expectation of working with multiple MAMs. If that were to happen, then I'd hope that SDK would include this sort of token issuance and request semantic. Because if that were the case, then an app could be written against this standard SDK. It could find itself installed onto various devices where, theoretically, independent of which MAM was on the device, it would just work. And it would also be able to ask for the tokens that it needs to call back to its API. I think that's the dream.
So if that's the dream, I'm going to guess that right now you guys are talking to all the individual vendors trying to get them to at least adopt this, since you don't know who's going to win and what the standard's going to be yet.
Yeah, we're talking to a number of those players, largely driven by shared customers. We have large enterprise customers who've invested in these providers and clearly want their identity infrastructure to work with their application management infrastructure. So we're having those discussions, and we're learning from them about that space, and hopefully they're learning from us about the identity space. But we're also working to standardize a protocol almost completely independent of how the MAM or that agent communicates with the business apps running within its container, is how that agent interacts with a network token engine such as Ping builds or our competitors build. So we want to standardize a protocol to allow such an agent to obtain from us or others the tokens that can then be handed off to the constituent apps.
So, and how far along are you with that standard, working with everybody in your industry?
It's very early days. The current reality is that there's a Google group where interested parties are just starting to talk about the use case and try to identify requirements. There's a draft spec. Currently, it's based on OpenID Connect, which is why I made sure to mention OpenID Connect earlier. Ultimately, I think that community, members of that Google group, will agree upon where the work should be taken. For different reasons, there's value in some sort of more formal standardization process. There's a number of different standards bodies that we might take that to. To some extent, that remains to be seen where we go next.
Okay. So we're kind of at the end here, but before we do that, I did promise you that I'd throw in an extra topic. You actually mentioned it when we first started, and one of the things that I see when I look at identity management and all that is, maybe we should forget about enterprise identity and just default to using Facebook or Twitter or Google or these people that already know who we are, and somehow interface those with the enterprise and do that. And I figured that would be a good question or topic to kind of throw your way, especially since you mentioned it earlier.
Yeah, so that trend is sometimes referred to as BYOI, bring your own identity. Riding the meme of BYO style. So there's lots of potential value there. From an enterprise point of view, if they can outsource the responsibility of managing their employees' identities, then theoretically that's a win. The current reality, though, is that an enterprise is probably unlikely to have sufficient confidence in how Facebook runs its identity infrastructure, how thoroughly they vet the initial registration of a user, how securely they protect the keys that are used to validate those tokens. An enterprise probably feels they can do a better job right now than Facebook or LinkedIn or equivalent. And until such time as there are trust programs comparable to what you described for EasyPass, where one state is willing to accept an EasyPass issued by another state, until there are equivalent programs that would give to the enterprise the necessary information and consequently the necessary assurance about a socially, an enterprise is probably going to just bite the bullet and continue itself.
Yeah, looking at it that way, personally I'd have trouble trusting Facebook, Twitter, Google, or the like just for the fact that I don't necessarily want them knowing what my employees are doing all day. And, some of that gets fed back to them. So
I think ultimately you could likely control that, right? Because while a Facebook might be asserting identity to you, it's up to you what activity information, theoretically, it's under your control as to how much of that makes it back to Facebook.
I like how you say theoretically. There are a lot of things that are theoretically possible, but a lot of people just don't do it right. So we're out of time this week, but Paul, let me give you a second saying, where can people learn a little bit more about identity and access management, and where's the best place to follow you on the web and on Twitter?
So on Twitter, I am Paul Madsen, first name, last name, nothing in between. Where can people find out about identity? I'm biased. I think Ping, irregardless if you're interested in our services or products, we try to be a useful source of information about identity. So even if you don't want to buy from us, steal our white papers. And on the web, I'm connected with an ID. Isn't that cute? .com.
So what we'll do is we'll actually put your Twitter handle and both the ping address and your own web address up on the show notes. So anybody who's actually listening to the recording can currently go to the cloudcast.net website, which is our proud parent podcast there, and look at the show notes and actually see where to contact you. And, thanks a lot, Paul. This has been really a great show. And if you like the show, please tell a friend. Leave us a review on iTunes. You can certainly follow us on Twitter at the Mobilecast, or on the web at thecloudcast.net, where you can find links to everything Cloudcast and Mobilecast. And, we're working on some great shows. Had a lot of fun here talking with Paul, and I'm sure that sometime in the future we'll have you back, Paul, to tell us what these standards are and where they're going from here.
Happy to do so. Thanks a lot, Brian. This was fun.
Thanks, guy. Thanks, Paul. And everybody, we'll see you next week.